You have probably seen it before. Someone moves a card in Trello and it instantly shows up on your screen, or a message appears in Slack without refreshing. That's the magic of real-time updates. And in today's episode, we're going to break down how it works and how we can implement it in your own front-end project. This is a part of my series called Frontend System Design Essentials, where I'm aiming to make key system design concepts clear, practical, and approachable, especially those that affect front-end developers. We look at the real-world challenges, things like normalization, virtualization, loading strategies, or optimistic updates, and walk through concrete examples so that you are not just hearing the abstract theory, you are actually seeing how these ideas apply in real code. In this episode, we'll look at how I build real-time updates in Fellow, a Trello-like application I'm building, using GraphQL subscriptions, WebSockets, and Relay. And more importantly, we will talk about when real-time is actually used for, what technique you can use, and what to consider when building this at scale. Let's get into it. Let's start by defining what we mean by real-time updates in front-end applications. In simple terms, real-time updates allows the UI to stay synchronized with the backend and with other users as change happen. This means if something changes on the server or in other users' browser, your UI reflects what changed automatically without needing any user interactions like refreshing or polling every few seconds, not waiting until the user clicks or navigates. Instead, the data flows from the server to the client as soon as it changes, and the UI responds accordingly. Now, where is this used for? Let's look at some common use cases. In chat app like Slack or Discord, new messages appears instantly. When user A types something in their screen, user B can see them, or like a group can see them instantly. In collaborative tools like Trello, Miro, Notion, or some kind of whiteboard, board updates or comments shows up across users in real time. In live dashboard, streaming metrics update without user input. In all of these cases, real-time sync is essential to the product experience. And that's what we want to build in Fellow, so that when one person moves a card, others see them instantly. So how does this actually work? Let's say I move a card in Fellow and you will look at the same board. What needs to happen for your screen to reflect that move in real time? Here is a high-level flow. I drag and drop the card to a new column. My browser sends a mutation to the backend and updates the card column and position. The backend processes the mutation and then emits a subscription event, something like card is moved. Your browser, which has been subscribed to card updates for this board, receiving this event over WebSockets protocol. Your front end updates the UI to reflect the new card position. This entire road trip from my action to your screen can happen in few hundred milliseconds, and with right tooling, the code to support it can be remarkably clean. That's where GraphQL subscription and Relay comes in. But please note that we are using GraphQL subscriptions and Relay just for the purpose of demonstration. That doesn't mean you have to band to this particular technique. It works perfectly fine with RESTful APIs or React query if you prefer to do the data fetching with that library. Let me show you how I implemented this in Fellow with GraphQL and the Relay subscriptions. So as you can see on the screen, I have two instances of Fellow running in my local. Fellow is just a Trello clone with a very minimum feature implemented. I use that to demonstrate some features of GraphQL and the Relay. Nothing fancy here, it's just a simple board. And if I drag one item in to-do from my left-hand side and drop it into the in progress, you can see that instantly the card is moved in another board as well. If I drag Hello Darkness, my old friend, again back to to-do from the right-hand side, the left-hand side also updated. So you can see that it's kind of synced. That's kind of mimicking the behavior that multiple users are looking or collaborating in the same board. The board is my project. And how do we implement that is kind of two steps. we firstly need to add a support in the backend. So we will need a mechanism to broadcast this change whenever a user moved a card. So subscription is one of the key types in GraphQL, so that can work with the notification mechanism. So now we have this card updated subscription, and then in subscription, whenever we define a subscription called card updated, and then it will for anyone that subscribing the board ID, it will listen on that event. I have a mutation called move card. So when user in the UI drag and drop a card, it will trigger this move card mutation. And we will do some regular checks, like if the user doesn't exist, we don't want them to do the interaction. And then we will do the call the API to move the card. And we have the return value is update the board. And then when we have that successfully moved, we will use the pub sub to publish an event. And in the event, we have a few details of what changed. So this is the event name, card moved on board. This is board ID. And then this is the data attached to that event. And for the subscriptions in here, it will, for whoever subscribed to that event, it will broadcast this change to the client. This is a server-side change. There is not too much to look into. And in the server, we have defined a new WebSocket server that building on top of HTTP server, which is like online express server that is our backend that's listening on the port 8080. So the WebSocket server is built on top of the HTTP server and listening on the GraphQL path. It's like the same endpoint. We can define a separate one, but I will keep it that for now. We will need to enable the subscription here. So the schema is the same schema we are defining for all the queries and the mutations. So in here, we using the same schema for subscriptions. And in here, we will just simply define this use schema, the context is same context, and then we will attach this web server we just created. And the start server will be called when we run the local node run start. So in local, so there is a command called start, and the server will start the HTTP server as well as the WebSocket server. So that means if I run npm run start from the backend server folder, it will compile the GraphQL, generate the data fetching part, and also it will start the server on port HTTP localhost 8080 GraphQL. And then in front end, I will use the relay to subscribe to that particular event. So what I do basically is define a new subscription. So subscription name, and the board ID. And I'm listening to this particular event. So when card updated is happened, I will try to fetch the ID, columns, and the columns fragment. The column has the ID, position, card. Card has its own fragment, which has the ID, title, the stuff. But in here, I'm just defining a subscription that listening to this event. And then in board component, we will use subscription hook to kind of hook them together, and it will listen on this subscription, and the variable for that subscription is the board ID, because in the subscription we will need to pass in the ID. It will only listen on event that happens to this particular board, not every board. And actually we don't need this on next here. So when we use a subscription hook inside the board, whenever a event happened in a subscription, we will get a notification, and it will have the data returned with that subscription. So we have the ID columns and all the card details attached to the columns, and that basically means everything. So in Relay, it has a cache, and then it will match all the ID and new data. So when it found the data returned from here, it can see what actually changed, and it will update all the references to the data, which means the board view will automatically refreshed. So to make it work, we will need firstly define a subscription and what data we are fetching when the event happens. And then we will need to use the subscription with the use subscription hook. That will automatically update the cache, the relay cache, when the subscribed event happened. And these two steps just connecting this subscription into your React components. And under the hood, if you haven't done that yet, you will need to, when you create a relay environment, you will need to define a subscription handler. It's pretty much like how would you do a fetch query handler if you are just fetching data. And for a subscription handler, you will need to define start the WebSocket protocol. So in here, we have a function called create subscription handler, which is basically establishing a WebSocket connection to your server. So you can see that we have a URL as a parameter passed into the create subscription handler, which is a WebSocket URL. And in that, you will create a client with GraphQL WebSocket, which is basically like upgrading your protocol to a WebSocket. I'm not going to dive into all the details for the subscription handler creation. So it's essentially it will establish a WebSocket connection to your server side with this URL, and then listen to the event to happen. And whenever a event we're interested in happened, it will then let the relay know it's time to fetch the new data, and we can get this into the relay store. Now let's say you are not using relay. Maybe your application is running with RESTful API or GraphQL without subscription, or you are using React query for your data layer. You can still build real-time updates, but it's a little bit more manual. You will need to set up a WebSocket connection using a client like Socket.io or GraphQL WS, and subscribe to relevant events. For example, the card move event. When an event is received, use something like query client.set query data from React query to update the cache. But now you are responsible for the cache management. You need to merge changes into your state model and avoid inconsistency or risk conditions. This approach works well, but you will want to be careful when scale up the complexity of your interactions. To summarize, the flow is started off from the board component. When we say use subscription, and for that particular given subscription, it will use the card update as the subscription name, and then in the create subscription handler, it will create that connection. And if we look at the browser in a network inspection, initially when we refresh the page, and at the very bottom here, you can see GraphQL, this WS is WebSocket, localhost 8080 GraphQL, and the status code is switching protocols. That means we are switching from HTTP to WebSocket. That means we have that connection established. And if you look at the overall status here, the result is 1.1, and the type is WebSocket. That all start from the create subscription handler line 17 in here. And in the meanwhile, for the backend, if we look at the code here, because we are subscribing the card updated operation name, and that will subscribe the client to this particular topic or subject. And you can imagine that as many clients are registering, they are all calling this subscribe function under the hood, and they will register themselves into a list. Basically, it's a listener list. You can think of that the backend will maintain this list. And whenever a mutation happens in a move card, and after the move successfully, and we will publish that event with such data attached, and all the clients that added to the list, the listener list, will be notified immediately. That all happens by this pops up, which is an in-memory publisher subscriber mechanism. it's a single instance running in a server side. So all the clients that registering to this server will all share this instance, and so when the event happens, it will notify all these listeners that attached to this pops up instance, so it can notify all of them. Now that we have seen how GraphQL subscription works in Fellow, let's take a step back and compare the three most common ways to implement real-time updates in front-end applications: polling, WebSocket, and GraphQL subscriptions. Let's go through each one. What is it, how it works, and when it makes sense. So polling is the simplest approach. The front end periodically sends a request to the backend asking, have anything changed, or like, is this ready? You might use something like set interval with a fetch call with some delay, like 500 milliseconds. This is very easy and straightforward. It works well with RESTful API and doesn't require any special backend support. But the downside is that you will need to send requests even when nothing has changed. It's like, are we there yet? Are we there yet? There's always a delay depending on your polling interval. And it doesn't scale well when many clients are polling frequently. Your server will obviously overload it. Still, for things like older status, background job, or basic dashboard, it's often good enough to have this mechanism. And for WebSocket, with menu implementation, the browser maintains a persistent connection to the server. The server can push data to client as soon as something changes. This gives you true real-time behavior with minimum delay. But as any menu steps, you will need to consider a lot of extra steps. You need to open the WebSocket connection, subscribe to specific events, and handle incoming message yourself. This approach works well with any backend, RESTful API, GraphQL, even your own protocol. But it comes with extra responsibility. You must handle cache updates manually. You have to reconnection when you lose the connection. And debugging circuit issue can be pretty tricky, especially in a complicated environment. And finally, the GraphQL subscription with Relay or Apollo, this is the way we just demonstrated. It's built on top of a WebSocket, but they wrap in more declarative, schema-driven format. Instead of manually listening to a raw event, we have the subscription like query language we are using with GraphQL. So it's very easy to integrate with your existing query or mutation mechanism you already have with the Relay. And the Relay will take care of opening the WebSocket, listening for the right events, updating local cache. It's efficient, clean, and tightly integrated with your existing data graph. But of course, this only works if you already have GraphQL, and your backend must support subscription transport like Apollo server, GraphQL Yoga, or similar. As you can see, each approach has trade-offs. I would recommend start with polling if you are just getting started or need a quick fix to implement the real-time updates. Use WebSocket or subscription if you are building a collaborative or interactive experience. And if you're already using Relay, GraphQL subscription is the best fit. So when building real-time systems, there are a few extra things to keep in mind, especially as your application grows. Each user typically opens a WebSocket connection to receive updates. That means your backend need to handle potentially thousands of open connections and keep them alive. If you are running multiple backend instances, you will need to coordinate events across them. That's usually done through a message broker or like a Radius or PubSub or Kafka. So when you have one single instance, everything is simple. User A doing some interaction, and the change is made through WebSocket, and then the user B can get that notification if the server is broadcasting through the PubSub mechanism. That works perfectly fine. But when you have like more and more users registered through the server, you will need to scale up. Normally you will have multiple instances in here. That means the user A registered or connected to the server A, and the user B is connecting to server B, but there's no way for them to know each other, the existence of each other. And if user A moved its card and on the server it broadcasts, but no one on server A that listening to this change or this event, like board ID 1. And we want the user B to be notified because they are interested in the event happens in board 1. So we would need to think of a new way that can carry on the message or like broadcast more broadly to different instances of the servers. So that means we will need to introduce a message queue normally. So when user A moved a card, it mutate the data, and then after that mutation, the server A will publish an event, like more centralized a message queue, and the queue will broadcast this change and to all the servers, and the server then relay this message to their clients, like all the browsers that are connecting to the particular server. So that way you can scale it pretty well. For example, if the user A or the server A even is living in one region of the world, and the other one, for example, this one is in another continent, they can still get this notification. But that also have their own challenges, like the message queue itself will be a single point of failure, and you will need to handle all the skill of this message queue itself. But that will be beyond our discussion in this video. You will also want your front end to handle disconnection and reconnection gracefully, especially for mobile devices or long-lived tabs. Another common concern is stale state. If users can make change to the same data at the same time, you need some form of versioning or timestamps to ensure consistency. And of course, don't forget to clean up your listeners when the component unmount to release the resource and close the connection. That's an easy place to leak memory if you are not careful. Now here is something worth highlighting. In one of my previous videos, the direct-to-boot refactoring example, I show how to implement a live polling system to check the state of the order. That polling logic works well. You basically need just keep retrying until the order status is changed to ready. And this is the right choice when you are just getting something working, or when the backend doesn't support the subscription mechanism. But if you are building it today, we could absolutely using GraphQL subscription to push notifications updates instead of polling periodically. So if you have seen that video, keep in mind polling is a good starting point, but subscription can be a more scalable and efficient long-term option, especially for real-time use cases. If you are working with shared data, collaborative tools, or interactive UIs, adding real-time support can make a big difference to the user experience. And if you found this video helpful, check out the rest of my Frontend System Design Essentials series, where I go deeper into performance, state management, loading strategies, optimistic updates, and more. Thanks for watching, and I will see you in the next time.